Hello everyone, my name is Anu Agrawal and today I'm gonna tell you about infinite dimensional space and its example. So first we should know that what is finite dimensional vector space. A vector space V is called finite dimensional vector space if there exists a basis for V which is with a finite number of vectors. For example, the trivial vector space V is equal to 0 is considered finite dimensional with dimension V is equal to 0 even though it doesn't have a basis. Here dim V is equal to 0 means the number of elements in V are 0. So this is an example of finite dimensional vector space. Now come to the infinite dimensional vector space. A vector space V is called infinite dimensional vector space if there is no such basis exist for V with a finite number of vectors. So here is a note that is containing the infinite dimensional vector spaces arise naturally in many areas of science and mathematics. Here are some examples of infinite dimensional vector space. So the first is the space of continuous functions of compact support on a locally compact space say R. The space of compactly supported smooth function on Rn. The space of square summable complex sequences commonly known as L2. This is the prototype of all separable Hilbert spaces. The space of all bounded sequence, the set of linear operators on an infinite dimensional vector space, and the last one is the set of all Schwartz functions. So these spaces have considerable more structure than just a vector space. In particular, they can all be given some norm. Now come to the theorem regarding finite dimensional vector space. Any two bases of a finite dimensional vector space have the same length. Now come to the proof. Suppose V is a finite dimensional vector space. Let B1 and B2 be any two bases of V. Then B1 is linearly independent in V and B2 spans V. So the length of B1 is at most the length of B2. This is by the theorem. Here we are saying that the length of B1 is at most the length of B2. This statement came from the theorem which states that the length of every linearly independent list of vectors is less than or equal to the length of every spanning list of vectors. So if we interchange the role of B1 and B2, then what will we see? We see that the length of B2 is at most the length of B1. So by these two statements we can say that the length of B1 must equal to the length of B2. Thus we have proved the required statement which we have stated in the theorem. So here is a note which is containing that any two bases of a finite dimensional vector space have the same length. Then we can formally define the dimension of such spaces. The dimension of finite vector space is defined to be the length of any basis of vector space, and the dimension of V, if V is finite dimensional, is denoted by dim V. Thank you everyone.